Hello, students. I welcome you all for this continuation of lecture series on generative AI and agentic AI for mechanical engineers. So, in this particular lecture, we'll discuss the second unit, which is generative AI tools for design and manufacturing. So, this unit will cover about the image generation models. So, generative AI models are multimodal in nature. They may be used for text generation, image generation, video, audio. Multiple generation can be done. So this unit will cover about image generation. So first what we will do is we will discuss about the autoencoder, which is a variation of the typical convolutional neural network. So let's get into the lecture. So where we need these data. So autoencoder can typically be used for generating sensor related data. Typically used in modern aircraft and military applications. So it may be used in applications where data is very sparse in nature. So wherever the real experimental data is not available to that much extent, we can use this generative AI tools for image generation purposes. So that's the second application. So why we need synthetic data? So synthetic data are generally used for preparation of data where we can couple it with the real data. So we cannot use synthetic data appropriately. We need to combine it with real data to get the better output. So that is how we can combine both together. So first, we'll see an introduction to autoencoder and how it can be used. So the core application of autoencoder is that, as you can see here, it is a same CNN block only. So it uses the conventional CNN block. Wherever we use it, we use the same architecture here. As you can see here, it is the CNN architecture, but the way in which these things are arranged, they can differ from model to model. So in an autoencoder, there will be typically two blocks. One will be your encoder and next will be your decoder. So in the encoder block, what we'll do is think of it like this in a high level understanding. You can see it like in an encoder block, it will compress the image. So if you see the image of the dog, what it will do is it will compress it into a latent vectors. So the image will be compressed into vectors. That is done by the encoder. So then what the decoder does is decoder tries to recreate the image of the dog from the latent vectors. So it does not recreate the image from the dog image, but what it does is it tries to recreate it from the latent representation. So think of it like that. Think of it like this. I'm having a photograph. I'm using the photograph to draw a picture. So then I'm using the picture to recreate the photograph again. So the difficulty here is that if the photo, all the details in the photo are captured by this portrait or painting, then it can be reproduced as a photograph easily. But some details are left out in this painting, then what happens? Recreating it becomes difficult. So that is how you can understand this latent representation. So latent representation is nothing but they are vectors which represent the details of the image in a numerical form. So that is how you can make a high level understanding of this latent vectors. So the vectors are directly used for recreating the image. It is called as an autoencoder. If there is some variation done in this vectors, then the architecture becomes variational autoencoder, which we will see in the next lecture. But I hope you understood this picture. So this picture will give you a better understanding. So I am trying to recreate the original image using this encoder decoder architecture. So what it enables me to do is that by training the model to recreate the image again and again, the model learns the representation. So the weights of the model will be updated in such a way that when I give a new unseen image or an unseen vector to the decoder, then the uh, corresponding image can be recreated. So that is how this models work in practically. So such models can be used for recreating, as I said, synthetic data can be created using such models. So they are used for multiple applications. One such thing is for noise reduction. So if your input image is very blurry, then it can be recreated or restored to the original clarity using this autoencoder setup. So this is regarding the autoencoder. I hope you understood this. Next lecture we'll discuss about the variation autoencoder. Thank you.